In this particular lecture, we will discuss the convolution sum concept, and in order to explain the convolution sum, we will use one example problem. Here, two signals are given x of n and h of n. We need to find the convolution of these two signals. That is, we need to find out the output y of n of a discrete-time LTI system, whose input x of n and h of n are given. Now, if you look at this particular problem, here two signals are given as a sum of different impulse signals, sum of shifted impulse signal. So first we need to convert. So here we are approaching this graphical method. I'll explain the graphical method, how we can use the graphical method to solve this particular problem. There are different methods to solve this particular problem. Here I will explain what is graphical method. So you already explained one concept. This is the second problem in this particular series in convolution sum. Here x of n is given by 2 del of n plus 1 minus del of n plus del of n minus 1 plus 3 del of n minus 2. And we know that del of n means it's an impulse signal which is defined by 1 for n is equal to 0 and 0 for n not equal to 0. For a discrete time sequence, if you draw the impulse signal at n is equal to 0, the function magnitude is 1. Okay, there is a del of n, simply del of n, and here it is given as minus del of n. So simply we need to draw a signal whose amplitude is just opposite. It's minus 1 at n is equal to 0. Okay, so that's a signal minus del of n. Now we can think about the next signal, that is 2 del of n plus 1, and first we will write the definition for del of n plus 1. Del of n plus 1 means 1 for n plus 1 equal to 0, or if you rewrite, you can write n is equal to minus 1, and 0 for n plus 1 not equal to 0 or n not equal to minus 1. Means you can draw another graph for this del of n plus 1. Here the index value n is equal to 0 and minus 1, and this signal exists only at n is equal to minus 1. See, whose amplitude is 1. But in the question it is given 2 into del of n plus 1, means you can multiply it with 2, so it becomes 2. And here we can indicate the amplitude 2. So that is a signal 2 del of n plus 1. Similarly, if you observe del of n minus 1, del of n minus 1 means its exists at n minus 1 is equal to 0 or n is equal to 1. Or you can say when n not equal to 1, it becomes 0. And here the amplitude is 1, so you can simply draw a signal 0. This is the index value 1. At 1, the signal amplitude is 1. That is del of n minus 1. Similarly, you can draw another signal, that is del of n minus 2. Del of n minus 2 means 1 for n minus 2 equal to 0 or n is equal to 2, and 0 for n not equal to 2. So you can draw another signal which exists at 2. And here you can see the amplitude is 3, so you can put 3 here. So 3, so the amplitude is 3. Now you can see that x of n means the sum of all these signals. So for that, you can add all these signal, and if you add all these signal, you can see the first del of n is a signal which exists only at n is equal to 1. Sorry, n is equal to 0. So here you can draw a signal whose magnitude is 1. So this is del of n. Then you can see that 2 del of n plus 1. Sorry, actually we required minus del of n. So you need to draw another waveform which exists in the negative axis. So it will be minus 2. So this is a point minus 1. At n is equal to 0, there exists a signal which is known as minus del of n. And at n plus 1 or at n is equal to minus 1 exists a signal which is known as a 2 del of n plus 1. So this is a signal. And if you consider del of n minus 1, which exists at n is equal to 1, and the magnitude is 1, so here you can plot another signal. And at n is equal to 2, the signal amplitude is 3. So you will get x of n. Or I can write this x of n in another way, which we used in the previous problem, as a set Here you can indicate 2, -1, 1, and 3. So 4 values, and we need to indicate that reference point, that is n is equal to 0. So we'll put an arrow mark here to indicate -1 is located at n is equal to 0. Similarly, if you observe this particular equation, you can directly write this h of n. Now we know the concept. So if you observe this particular signal n minus 1, del of n minus 1 means a signal exists at n is equal to 1, and here the amplitude is 3. Okay. Similarly, at n is equal to -2, del of n minus 2 means a signal which exists at n is equal to 2, and here the amplitude is 4. Now we can think about the last signal, del of n minus 3, which exists at n is equal to 3, and here the amplitude is 2. So at n is equal to 0, the signal magnitude is 0. And you can write in this particular way, that is 3, 4, 2. Actually, there is 3 non-zero magnitude, but in order to indicate the reference point, you need to add an extra 0, and then you can say that this is starting point, 0. Okay. Otherwise, if you write simply 3, 4, 2, then we cannot indicate the reference point. So that's why we are adding an extra 0 here, and we'll make. Now, if you observe the starting point of the signal, because we need to calculate y of n for a different value, anyway, we'll think about that. So next case, see, this is the formula for evaluating convolution sum. Y of n is equal to x of n convolution h of n. We required x of k and h of n minus k. So in order to find h of n minus k, first we will find h of k, then h of minus k, then we will perform h of minus k plus n. And for different values of n, we will plot the signal. And in the question, it is given x of n and h of n. So simply we can find out x of k and h of k by changing the variable n to k. So you'll get x of k. It's exactly the same shape, but the variable is k. Similarly, h of n is given. You can draw h of k. Now we got h of n, h of k, and x of k. And if you know h of k, you can simply draw h of minus k. It's a time reversed version of the signal. Means here at n, k is equal to 1, the signal amplitude is 3. So if you take the time reversed version of the signal, h of minus k, at -1 you can draw 3. At 2, signal amplitude is 4, so you can draw at -2 signal with amplitude 4, and at 3 it's 2, so -3 can indicate 2. So this is actually h of minus k. Now we need to evaluate y of n for different values of n, because we required h of n minus k. So we need to calculate y of 0, y of 1, etc. And we don't know where to start. So we can find out, like, if you know the starting point of the first signal, that is n1. So here you can see that n1 starting point of the first signal. So x of n starts the non-zero magnitude at -1, and similarly h of n starts the non-zero magnitude at n2, that is 1 here. Okay, we'll consider only non-zero magnitude, that's why we are taking 1. Now we'll get -1 and +1, and if you know these two quantities, y of n will start from n1 plus n2, that is -1 plus 1, that is 0. So we need to evaluate y of n from 0 onwards. And n point you can find out simply finding the end point of x of n and h of n. See, here you can see that x of n is at 2, h of n at 3. Okay, the index value 2 and index value 3. So you can find it's simply 2 plus 3, which is 5. So we need to evaluate the signal from 0 to 5. And first we will take the example n is equal to 0. If you write n is equal to 0, your equation y of n becomes sigma k is equal to -infinity to infinity x of k into h of n minus k, n is 0, so you will get simply minus k. And we know the signal x of k and h of k. So we need to multiply x of k and h of minus k, and then we need to add. So if you look at this particular equation, the non-zero magnitude of x of k, it's at minus 1 at this particular point, and the corresponding value of h of minus k at we need to observe. So you'll get simply 2 into 3, which is equal to 6. In all other values, you will get only 0. Okay. So we don't want to evaluate any other value, because non-zero magnitude will get only at k is equal to minus 1. So we got not y of n, is actually y of 0 when n is equal to 0. So you can write y of 0. Now you can calculate our next quantity, that is when n is equal to 1. N is equal to 1 means it's simply y of 1. In the formula, if you substitute n is equal to 1, it becomes k is equal to minus infinity to infinity x of k into h of 1 minus k. See, if you know h of minus k, then you can simply plot h of 1 minus k, simply shifting the h of minus k 1 unit towards right. So you can see the entire signal is shifted to 1 unit right. So h of minus k is starting from minus 3 onwards. So if you shift, it will start from minus 2 onwards. Now we need to find the product of x of k and h of 1 minus k, and we need to add. And if you observe the signal x of k and h of 1 minus k, at minus 1, the first signal amplitude is 2, and h of 1 minus k amplitude is 4. So you'll get 2 into 4. Next signal, the amplitude is minus 1, into second signal amplitude is 3. So you'll get 8 minus 3, which is equal to 5. Okay, you got the second signal. Now we can calculate at n is equal to 2. If n is equal to 2, uh, if we evaluate this particular equation, convolution equation, y of 2 becomes sigma k is equal to minus infinity to infinity x of k into simply h of 2 minus k. And if you observe the signal h of 1 minus k, and now we need to draw h of 2 minus k. It's simply 1 unit right. So you can shift the signal h of 1 minus k towards right side 1 unit, you will get h of 2 minus k. If you take the reference h of minus k, you need to shift 2 unit. But if you take just previous signal h of 1 minus k, you need to shift only 1 unit, that is h of 2 minus k. Now we need to multiply h of k and x of k and h of 2 minus k, and now we can write y of 2. If you write y of 2, you can see that it's 2 into 2 plus minus 1 into 4 plus 1 into 3. So you'll get 4 minus 4 plus 3. So you'll get 3. So third value is 3. Now we can evaluate at n is equal to 3. If we evaluate at n is equal to 3, the equation becomes y of 3, which is given by sigma k is equal to minus infinity to infinity x of k into h of 3 minus k. And we need h of 3 minus k. If you know the signal h of 2 minus k, you can shift the signal towards right 1 unit. So you'll get h of 3 minus k. And now we need to multiply the signal x of k and h of 3 minus k. Okay, if you observe the signal uh, x of k, so x of k is here, and h of 3 minus k, you can see that the signal non-zero magnitude only starts from 0 onwards. So at 0, it's minus 1 amplitude. Here it is 2. Next case, at 1, the signal amplitude is 1 in the first case. Second signal amplitude is 4. And third point, at k is equal to 2, first signal amplitude is 3, and h of 3 minus k amplitude is 3. So you will get minus 2 plus 4 plus 9. Okay, you will get 11. So n is equal to 3, you will get 11. Now we need n is equal to 4. At n is equal to 4, you can write y of 4. So y of 4 is equal to sigma k is equal to minus infinity to infinity x of k into h of 4 minus k. And again, if you shift the just previous signal h of 3 minus k 1 unit, you will get h of 4 minus k. And if you take the reference h of minus k, you need to shift 4 unit. If you take h of 3 minus k, only 1 unit. Now we need to multiply the corresponding signal values. If we consider x of k and h of 4 minus k, the non-zero magnitude start from 1 onwards. So you can write y of 4 is equal to 1 into 2 plus 3 into 4. Okay, and after that you will get 0. So 2 and 12, so you'll get 14. Now the last case, n is equal to 5, that is y of 5. So in order to calculate y of 5, you can substitute n is equal to 5 in this particular convolution equation. So it becomes x of k into h of 5 minus k. And after substitution, y of 5 is equal to, if you observe the signal x of k, and we know that h of 5 minus k will get by simply shifting h of 4 minus k towards 1 unit, right? So here non-zero magnitude start from 2 onwards, and here the signal amplitude is 3. So you can write 3 into 2, so that is 6. So we got all the values. Now we can conclude the final result. That is, you can write y of n. Y of n is equal to, if you start from first point, it's 6, 5, 3, 11, 14, and 6. Okay, we got different values. This is the starting point at 6, and if you draw the waveform for different values of n, start from 0, 1, 2, 3, 4, and 5. So at 0, the signal amplitude is 6. At 1, it's 5. And at 2, it's 3. And at 3, it's 11. At 4, it's 14. And at the last point is again 6. So this is a signal y of n. 6, 5, 3, 11, 14, and 6. Thank you.